Hey guys, it's me again. So imagine this. You're sitting near a pond on a beautiful, breezy summer day, and you've got nothing to do. You're bored out of your mind. You're so bored, you start tossing objects lying on the ground into the water. Rocks mostly, which sink, right? Then you wonder, what can I toss in the pond that would float? My brother? Maybe, maybe not. Then you see some twigs and some really heavy-looking logs lying nearby. Will they both float? From experience, we know that wood floats on water. Duh, but why? I mean, one log is way heavier than a whole mess of twigs. What would your chemistry teacher say? You seem to remember something from the 8th grade about density. Whoa, hold on. Let's review some things you should already know for sure. Chemistry developed from observations about the nature and behaviors of different kinds of matter. These observations tell us about the properties of matter. What's matter? It's what everything's made out of. Let's look at a more formal definition. Oh, okay. So now you remember all that stuff you learned about matter, that it can exist in a solid, liquid, or gas form. Ring a bell? By observing matter and measuring it for its various properties, we can gradually get enough information to tell it apart from other kinds of matter. Scientists study different kinds of matter and the transformations that happen between them. A property is a description of matter. Let's take a look at that definition. Properties of matter can be divided into two categories: intensive and extensive properties. Hey, don't tune out just yet. Let's think about the pond again. You notice the log and the twigs come from the same tree, so they must be made of the same thing. You decided to grab a handful of twigs and one fat log and get all scientific on them. You take them back to your chemistry classroom and place them one at a time on a balance. You measure the mass of the log to be 15 kilograms. The mass of the twigs is only 15 grams. The mass of the log is 1,000 times greater than the mass of the twigs. Yeah, so what? Well, you just measured an extensive property. Let's take a look at that definition because it's pretty important. Great, we have the mass. So what does this tell us? Nothing really. Even though the log has a greater mass than the twigs, they both float. We're going to need some more information. I think you know where this is going too. In order to explain why both the log and the twigs float, we've got to look at the density. Back to our experiment. I think it's safe to assume that the log and the twigs are made from the same thing since they didn't fall far from the same tree. You grab your trusty graduated cylinder from your back pocket and measure the volume of the twigs using the displacement method. Then you borrow your chemistry teacher's heavy-duty cylinder to measure the volume of the log. You just measured the volume, another extensive property, yo. The log displaced 1,000 milliliters of water. The twigs, only 1 milliliter of water. By using the density equation, you find that both the log and the twigs have the same density. Surprised? Yeah, I didn't think so. But guess what? Yep, you got it. We just measured an intensive property. Let's look at that definition too, because just like extensive, it's pretty important. So whether you've got a whole bunch of twigs or just a few, a fat log or a skinny log, the density will always remain the same. Density is an intensive property. The mass and the volume will change if the sample is small or big. Mass and volume are extensive properties. Density, temperature, color, hardness, melting point, boiling point, and freezing point are all examples of intensive properties. Okay, so why do we care so much about intensive and extensive properties? Well, not too long ago, someone sent an envelope to the president containing a mysterious white powder. What was it? Was the powder flour, sugar, or something a little more dangerous? Well, is it safe to taste it or smell it to see what it is? Better not. By measuring the intensive properties, such as the boiling point and the melting point, and comparing their data to the known boiling point and melting point of common substances, chemists were easily able to rule out flour and sugar as the culprit. It was actually ricin. Yikes! That's why you never want to taste anything in the lab, guys. One more thing. How do I keep from getting these two properties mixed up? Look at your T-chart. There are way more intensive properties than extensive properties. You've just got to tell yourself, this list is intense. Most of them are intensive properties, except for 3: mass, volume, and length. These are excluded from the intense group. So really, all you have to memorize are those 3 extensive properties. The rest are intense. That's it for now, guys. I'll see y'all later.